Tried to think ahead. And then I have 3D's down here, and then I can cancel that with 3D's on top. So let's see, I have 2D's, and I have a 3, and I have 1 in the denominator, so I have 3D squared over 1, which is just 3D squared. Okay, number 14 is f squared over 3 plus 6f squared over 6. Alert, 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 alert. We're adding. What do we have to do when we add fractions? We need a common denominator. This is an easy one. What would the common denominator of 3 and 6 be? 6. So I have to multiply this times 2 and the numerator times 2. So I get 2f squared plus 6f squared all over my common denominator of 6. Multiply these both by 3 so that this would have a common denominator of 6. They both have a common denominator of 6. Now, 2f squared and 6f squared are like terms. That's 8f squared over 6. Monomial, monomial. Slice it and dice it, baby. Now let's think about this. 4 times 2 and 2 times 3. Looks good. My 2's cancel out, and I'm left with 4f squared over 3. Okay, number 15. 12ab over 5 minus 7ab over 5. Okay, what are we doing? What are we doing? We're subtracting. When I add and subtract, I need common denominator. Do I have one? Yes, I do. It's 5. So now I'm just going to subtract my numerators. 12ab minus the monomial 7ab. Well, 12ab and 7ab are like terms, and if I combine these like terms, I get 5 positive ab's over 5. This is a monomial, baby. No addition or subtraction signs. Bust it up and I get 5 times a times b over 5. Your 5's cancel out and you're left with ab over 1, which is just ab. Woohoo! Number 16. X plus 3 over 5 minus x minus 2 over 15. Okay, a couple things you got to notice here. Alert, alert, alert. Subtracting, we need a common denominator. Number 2, alert, alert, alert. We're subtracting here. We have to subtract everything in our second numerator. Not just the x, not just the negative 2, but everything. So hold that thought. What's our common denominator going to be? Well, this is an easy one. I can make 5 become 15 by multiplying it by 3, but if I do that in the denominator, I better do it in the numerator, and I better multiply every stinking term in my numerator. So I get 3x plus 9 over 15. There's my first fraction. Now I'm going to subtract all of this. This is already over 15. I don't have to mess with the denominator. But I do have to subtract every stinking term, so I'm going to distribute a negative 1 to every stinking term. Over and over, I see students subtract x, but then they don't subtract the second term. So what's going to happen here? Negative 1 times x is negative 1x, and negative 1 times negative 2 is positive 2. That sink in. Negative 1, negative 1x. Negative 1 times negative 2, negative times a negative is a positive. Now I'm going to combine 3x and negative 1x, and I'm going to get 2x. And I'm going to combine 9 and 2, and I'm going to get positive 11 over 15. This is a polynomial, so when I look at my menu, no GCF, it's not a PST, it's not dots, and it's not a trinomial. I can't use X-Man, so this can't be factored. 2x plus 11 is as good as that's going to get. Now I could factor this, since it's a monomial, and call it 3 times 5, but that's not going to help me because I don't have a factor of 3 or 5 in my numerator. So I'm just going to put my 3 times 5 back together, and that would be my final answer. Okay? Groovy, kids.